Welcome back to Amazing Earth. This is level 2, which we've been talking about fast land changes. This mission will focus again on how Earth's resources change through talking about volcanoes. But first we're going to look at our key point, which is Earth's surface is constantly changing. These changes occur either slowly through weathering, erosion, and deposition, or rapidly because of natural disasters like earthquakes and volcanoes. Humans can also change Earth's surface both positively or negatively. By studying Earth's changes and natural resources like minerals, rocks, and soil, humans can determine how to use natural resources to survive and where to build structures used for living. As I said just a moment ago, this mission will be on volcanoes. Our mission objective is to explain how volcanoes quickly change Earth's surface. Our challenge questions are: how do volcanoes form? So what causes us to be able to see volcanoes on Earth's surface? What are the 3 types of volcanoes? So the names of those different types of volcanoes. What is the difference between active, dormant, and extinct volcanoes? And name one effect of a volcano to Earth's surface. So one thing that happens on Earth's surface because of a volcano. Before we get started, we're going to watch this brief video that will explain many things that we're going to talk about throughout this mission.
Volcanic eruptions can be spectacular, and volcanic landscapes are eerie and intriguing. But volcanoes are also highly destructive. Since the 18th century, they've killed more than 250,000 people. Most volcanoes occur at certain locations across the globe. These locations often coincide with the boundaries between Earth's tectonic plates. Underground volcanoes frequently are found at divergent plate boundaries. The molten rock or lava that bubbles up creates new seafloor. Other volcanoes, such as those that created the Hawaiian Islands, are formed over what are known as hotspots. Hotspots are areas of molten rock beneath tectonic plates. As the plates pass over the hotspots, the magma shoots up through the crust, creating a volcanic mountain. The plate's movement serves as a conveyor belt, resulting in the formation of a chain of mountains. Many volcanoes also occur at convergent boundaries, where 2 tectonic plates meet and one is thrust beneath the other in a process known as subduction. Part of the plate that sinks is melted by Earth's heat and forms magma. The magma is mixed with gases created when the rock melted. The magma is under great pressure. It creates a channel in a part of the rock that is weak or fractured. The magma blasts to the surface through an opening called the central vent. At the surface, the magma is called lava. Some volcanoes erupt far more violently than others. The difference depends on the composition of the magma, specifically the amount of silica and water. Silica is the main component in about 95% of Earth's rocks. It's a mineral made up of silicon and oxygen. Magma with little silica has smaller amounts of gases such as carbon dioxide. It flows easily and is less explosive. Magma with high silica content is sticky, travels slowly, and often has a lot of dissolved gases such as water and carbon dioxide. It is very explosive. Volcanic eruptions also create pyroclastic flows, deadly avalanches of hot ash, pieces of rock, and gases. With speeds of 100 kilometers an hour and temperatures as high as 700 degrees Celsius, a flow is capable of destroying everything in its path. There are different types of volcanoes based on their shape and whether they were formed from sticky or free-flowing lava. Shield volcanoes are made from free-flowing lava that spreads widely. They are low and dome-shaped. cinder cones are formed from magma that is so sticky it erupts in fragments, anything from tiny particles to chunks the size of a basketball. The lava builds up around the vent. Composite volcanoes are made up of both fragments and free-flowing lava that harden in alternating layers. These are tall, mountainous forms. As volcanoes explode, collapse, or erode, they create distinct geological formations. An atoll is a circular coral reef that grows on top of a volcano that is sunk below the surface of the water. A caldera is a large crater created when the top of a volcano collapses, either during an eruption or afterward. A neck is solidified lava that plugs up the opening or conduit where the eruption occurred. Scientists have an array of instruments to help them study and predict volcanic eruptions. Before a volcano erupts, it expands slightly. A device called a tiltmeter measures the expansion. Thermometers check increases in temperature, another warning sign of volcanic activity. And seismographs detect earthquakes, which often precede an eruption. Volcanoes and earthquakes are two of the most powerful and frightening natural forces on our planet. The theory of plate tectonics has provided scientists with an understanding of the relationship between tectonic plates and these two major geological events. But there is still much we don't understand about volcanoes and earthquakes. Geologists continue to fine-tune their tools and try to uncover new data to shed light on these two forces of nature.
Volcanoes are an opening in Earth's crust where gases, ash, and molten rock can reach the surface of the Earth. Volcanoes take a very long time to form. They don't just happen overnight. They take very long time to form, many, 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 many years. When they erupt, they can change Earth's surface very, very quickly. Maybe you didn't know this, but volcanoes can form under dry land, so on the land that we see, or even underwater. And volcanoes can erupt at any time without any warning. So that makes them pretty dangerous to be around. Let's talk about some volcano vocabulary. Magma, which is rock that turns into liquid underground because of heat. We talked about that in level 1 with the rock cycle. Lava is simply magma that has reached the surface. So when it's inside of a volcano, we call it magma. But when it comes outside of a volcano, then it's become lava. But really, they're the same thing, just different names. A vent is an opening in a volcano. And the crater is the main vent of a volcano, which is usually bowl-shaped. Then we have ash, which is smoke that comes out of the crater. You'll need to know the difference between those 5 vocabulary words and where to put them on a diagram. And here you see a diagram of a volcano. Notice the magma, that's inside Earth's surface. It comes up through a vent and then out the crater, and once it's out of the crater, we no longer call it magma, we now call it lava. Volcanic eruptions occur when liquid magma and gases from beneath Earth's crust find a way to escape between a gap in tectonic plates. In other words, they burst to the surface through a vent. So as we've talked about tectonic plates, remember how they line up against each other, and underneath them is that hot magma right at the top of the mantle. And occasionally there will be an opening on Earth's crust because of those tectonic plates. They have moved, and when that happens, magma comes up between that vent and volcanoes begin to occur. The Ring of Fire is the location on Earth where many volcanoes occur. You can see that from this picture. Many of the volcanoes, which is shown in kind of the triangle there, happens in the ring of fire, and those are usually right where tectonic plates meet. Each type of volcano produces a different kind of eruption. Appearance, the way that it looks, would predict that type of eruption. There can be violent volcanoes, which are very explosive, which destroy parts of the volcano with very steep slopes. There can be non-violent volcanoes, which are calm and builds up more volcano with gentle slopes, so meaning that the lava doesn't flow out as quickly and actually builds more of the volcano after it's done erupting and the lava has cooled. The three types of volcanoes we're going to talk about are the cinder cone, the shield, and the composite. Let's first talk about the cinder cone. Cinder cones form very, very quickly because they have very steep slopes. They get their name because they are usually shaped like a cone, as you can see here. There is no lava flow really that comes out of a volcano. It just kind of, out of a cinder cone volcano, it just kind of, the lava just kind of rests right on top of that cone. It sprays ash and lava into the air. Here you see an example of a cinder cone volcano. Notice how up at the top there's that little indentation. That's where the lava settles in the volcano. That's why we said there's really no lava flow. It kind of just chills up there after it has been released from the volcano. Then we have a shield volcano. A shield volcano cools very slowly because it has gentle slopes. It's non-violent, meaning that the lava is very slow moving, which is good. It'll give a lot of people time to evacuate if they need to, if the magma is slow moving. It usually has a large crater at the top, and it looks like a shield, which is where it gets its name. Here you see an example of a shield volcano. Notice the very gentle slopes. They're not very steep. That lava will come down very, very slowly out of that volcano. And finally, we have a composite volcano. Composite volcanoes are steep and wide. If they're steep and wide, that should tell you something about the violence of the volcano, meaning that they're very, very explosive. Sometimes they are also known as a stratovolcano. So stratovolcano and a composite are really the same thing. Here you see an example of a composite volcano. This volcano actually would erupt a couple years after this photo was taken, but notice how steep the sides are. This is Mount St. Helens. This is a volcano very famously erupted many years ago, but notice how it's very steep, which means the lava is going to come out of there pretty quickly. It's going to be a pretty violent eruption, which it was. Here's an important question. Do all volcanoes erupt? Well, no. The answer, pretty simply, we have three different types of volcanoes when it comes to thinking about whether they're going to erupt or not. One is called the active volcano. The active volcano means that there are frequent eruptions, or that scientists can see signs that this volcano will erupt in the very near future. Then we have a dormant volcano. A dormant volcano is just a volcano that has not erupted in a very long time. And a dormant volcano still can erupt, and it's very dangerous when it actually does erupt. Dormant volcanoes are volcanoes that have not erupted in a very long time, and they are very, very dangerous. And then there's an extinct volcano, a volcano that scientists do not believe will ever erupt again. That doesn't mean that they won't erupt again, but it's probably pretty likely that they won't erupt ever again. What are some effects of volcanoes? Well, there's massive destruction because lava is very hot and destroys everything in its path. Buildings, roads, you name it. It destroys everything in its path. If it's an underwater volcano, it can actually create volcanic islands. The Hawaiian Islands in the United States are an example of volcanic islands. It can also cause climate change, and that's an example of that is actually in your science book, and we'll look at that in class so that we can understand that. They can also cause other natural disasters, which we're going to learn about next mission, like tsunamis and landslides. Let's summarize this mission before moving on. A volcano is an opening in Earth's crust where gases, ash, and molten rock can reach the surface. It takes volcanoes a very long time to form, but they can cause very fast changes to land. So while it takes them a long time to form, the damage that they cause and the changes that they cause to Earth's surface can happen very quickly. And there are 3 types of volcanoes: the cinder cone volcano, the composite volcano, and the shield volcano, that are classified by how they look, by their appearance, and their violence, how quickly and how devastating their eruption is. It is now time for the end of this mission. If you have any questions, please let me know. Make sure you have those challenge questions answered, and I will see you in mission 4.